Permissioned blockchain networks that require every peer to execute every transaction, maintain a ledger, and run consensus can't scale very well. And they can't support true private transactions and confidential contracts. So the Hyperledger community designed Fabric v1 to deliver a truly modular, scalable, and secure foundation for industrial blockchain solutions. The most notable change is that peers are now decoupled into two separate runtimes with three distinct roles: endorser, committer, and consenter. Here's how it works. Say you run an organic market in California, and I grow radishes on my farm in Chile. You and I are on a blockchain network that supports transactions between various markets, growers, shippers, banks, and others. Say I agree to sell you my radishes at a special low price, but I need the other markets that buy from me to continue buying at the standard price. They shouldn't be able to execute our confidential agreement and find out the details of our deal. In fact, if they aren't part of the deal, the transaction shouldn't appear on their ledger. Fabric v1 handles all this. My app looks up your identity from a membership service and then sends the transactions only to our peers. Both of our peers will generate a result. In this two-party agreement, the transaction requires both of us to render the same result. But in transactions with more parties, other rules can apply. Then the peers send the validated transaction back to the application, which sends it to a consensus cloud for ordering. And then the ordered transactions are sent back to the peers and committed to the ledger. But to get my radishes to your market, there are many other parties involved. Some need to know that my radishes have been verified and checked into a shipping container. Others need to handle bills of lading, customs inspections, financing, insurance. But most of these parties don't need to know about our special price. Now think about our transaction running on a network handling all the markets, all the farms, shippers, facilitators, the whole supply chain. This is the same pattern needed by many industries. Anywhere we need to manage confidential obligations to each other without passing everything through a central authority.
Okay, that's a fun video, right? If you guys haven't figured out, we're getting in the radish business. So I'm Jason Normandin. I get to talk to you about what blockchain is and why it's neat and interesting and why there are advantages for us to pursue the technology. So let's start with defining exactly what blockchain is. And it's really hard to do that without at least mentioning and passing Bitcoin. And that's because back in 2009 when Bitcoin was invented, the guy or guys that actually invented Bitcoin wanted to create a system or a network that could be used for people to buy, sell, trade Bitcoin. And they wanted to do this in a way that was decentralized, so nobody actually owned the system or the data. That could be used by a lot of people. And nobody could screw with the data or mess with it once it was in the system. So you couldn't change the numbers or fudge the data or anything like that. So what they invented is this thing called blockchain. And blockchain's a system with some pretty definitive characteristics. And one of those is going to be that in a blockchain system, your data is distributed. So it doesn't live just in any one place. It's not going to live on just one server. And to use NAR as an example, it wouldn't just live on one server at NAR. If we had a blockchain for associations, a copy of that data would live with every participant of that blockchain. So it would live in multiple locations on the network. It supports really, really robust rules for who gets to see data, query data, update data, write changes to the database, that sort of thing. More robust than existing databases provide. It's built from the ground up to be secure, and it uses probably stronger encryption than any existing database system does out of the gate. Accessing the data, submitting requests, even joining the network. Every single transaction requires verification of your, the identity of the person accessing the data and the permissions, that the data hasn't been modified or adjusted in any way. Basically, soup to nuts from the ground up. We're talking built-in heavy-duty encryption to the point where it causes issues when we're implementing it. And the data is immutable. You can't change it once it's in the system. Essentially, when you're writing data to a blockchain, provided that it passes all the business requirements and you're allowed to write the data in, the way the business rules apply the data is it'll take it and form a block of records and write it to the database. And every subsequent write to that database won't replace any of the data that's already there. It'll simply create a new block of records, essentially above it, with a link to the old block. And then goes in sequence like that until you essentially have a chain of blocks, a blockchain. None of the old data ever gets deleted. It's all there in perpetuity. But I do want to talk about what's essentially the most common business model that we use right now. And that's, you've got one trusted agent here who runs a system, and everybody accesses it. They write data to the system, they read from it, and it's essentially a standard database backend for member records, or for MLS records, or for title records, anything along those lines. What we're essentially talking about is where it makes sense to leverage a decentralized system with really, really strong business rules for accessing data, for updating data, and where we need to cryptographically protect that data because it's important to switch from a standard model like this to something that looks like this, where we've got a bunch of players or a bunch of participants on one network. They all have copies of the data that are in sync. We know that everybody's working on the exact same data set. And all of the data in the system is cryptographically protected. So when we're looking at something like this, we can envision a shift away from the functionality we've got right now to something a little bit better. And that's, just to use an example, what if we could store property title data in a blockchain? And when we went to access that data, we could verify that that the data in the system is cryptographically signed, so it hasn't changed, and the data in there is valid. And that would take a property search down from days to seconds. What if we had a system where we were storing MLS and property data, and you as a member could go in and access that, and you would see property data going back all the way through to the inception of that system or that database. Or what if we applied these protections, this cryptographic protections, these strong business rules, and this decentralized data model to something like your member data, where if you changed associations, your history would follow you, and the new association would be able to see your committee membership history, and would be able to see your CE credits, and whether or not you were current with other training requirements. But nobody else could. That's the kind of thing that we're talking about being possible just with the new functionality that we would see with a blockchain model. So why is NAR involved in blockchain? Blockchain's getting a bit of hype right now, and certainly, we've seen a lot of technologies come to the foreground. We've seen and the fads are numerous. We've got QR codes and cloud computing and netbooks and all these things that were supposed to really change, segues that were absolutely supposed to change the way we do business or the way cities are built. And they certainly don't all deserve the amount of hype that they get. But something like blockchain, where it really brings something new to the table, it at least deserves, and we need to actually step in and see how much of that's legitimate, where it makes sense to apply the technology, and get some business acumen in actually leveraging something like this. So with that said, I hope you understand a little bit of what a blockchain network actually is. I'm going to turn over to Jose Ramirez, who's going to talk a bit about what NAR has actually been doing with blockchain and what we're learning.
Before I start my slide, actually, I just want to make sure that all members are aware that the data that we're planning to actually use for testing purposes only right now, is actually already existing. It's already on the NERD system. You guys already have access to all of these systems, and the data already exists. Blockchain will not be doing anything new as far as data controlling. The only thing that it's going to provide to members is literally tools for members to actually access with historical records and securing all of your data. That's all we're testing right now. And as far as I'm concerned, there's not even plans on going on production anytime soon. So far right now, the only thing that we have been doing is that we have been testing how blockchain actually interacts with member data for any transactions, as far as like a transaction could, like a member has relocated from one association to another association. That's pretty much it. That's all we've been actually doing with testing blockchain technology right now. So regarding the slide, this is where we're at right now. For the last few months, NAR has been testing, designing, and deploying a couple of systems. One is just a small system in our internal data center, nothing external, just internal, with a couple of tiers. Actually, the lab system is on 4 peers. So when I say peers, I'm talking about systems, separate physical systems working as one, sort of like a cluster system. It's not literally like a cluster system. It works differently because of the blockchain technology, the security, and the way it auto-syncs itself. So the second system that we have actually developed is actually just a dev system. This one is a little bit more robust. It actually is online on the internet, but it's only accessible to a couple of states right now. It will eventually have 6 peers nationwide. These 6 peers will eventually be located in different parts of the US region. A couple of them will be on the East Coast. A couple of them will be on the West Coast. And a couple of them will be in the mid-central region. Currently, we only have developed and added 2 peers to the system. The 2 peers that are online right now is actually New Jersey and Chicago. Those are the only 2 peers right now online on the cluster system. We are planning to add 4 more. The 4 other systems that we're planning to add is actually going to be California, Indiana, Massachusetts, and California, Massachusetts, Indiana, Florida, and that actually completes the 6 of them. Once the system is actually built on the dev system, it will be a decentralized system. We're not talking about centralizing our system any longer, because that creates a lot of issues as far as, like, let's say that you have a centralized system in Chicago and everything is literally in that system. Something happens to that region, to that data center, or to that system, everything goes down. So now we're trying to stretch the blockchain system and thinking big. We're talking about nationwide. The way we're actually planning to do that is that we actually going to have the 6 peers. California is going to have one. Massachusetts is going to have another one. New Jersey already has one. Illinois already has one. Florida will be next, and then Indiana. Once we have all these 6 systems working as one, updating all of the ledger information with any data you as members want on the system, And just have in mind that blockchain technology is literally just a system, a technology, and a tool that you guys can use for any type of system environment. You guys can actually request to have a system for your member data. You can actually request to have a system for any property, movement, transactions, events, or anything that you guys want to have on the blockchain system. Blockchain is so secured that it uses so many different layers of security. Literally from when you log into the portal system, you will be signing in with single sign-on, for example. Once you pass that security feature, you will actually have another set of systems going to any of those peers to update any data that you want on your system, your environment, or anywhere where you actually apply the blockchain technology. Let me give you a sample of a transaction. Let's say that a participant or an orderer is actually assigned to do data entry on the blockchain system. The transaction will actually be secure via multiple layers of security, including cryptography technology on all the block peers. That means that all of the systems, all of the servers will literally be validating public keys, SL certificates, and private keys before even committing any data to the ledger. Once the peer is actually applying any data to your ledger, depending on your system data, it will eventually publish securely all of the data ledger that was just recently updated to the rest of the peers. The rest of the peers, no matter where they're at, via the network, via the internet, let's say that you update one in California. As soon as that one gets updated, the one in Massachusetts will eventually see it, actually instantly see that there's an update to one of the ledgers and grab a copy of the update and update its own local database. Each one of these peers will have a system built with a database and multiple system components, including the security, and updating itself from the rest of the peers nationwide. Regarding production, I don't foresee us actually even working on a production system yet, because the technology that Hyperledger, Fabric, and the peers and all the applications are still at their very early stage right now. They're changing so fast that within the last 10 months, we have gone from version .9 to version 1 to version 1.0, 1.1, and then version 1.2 just came out literally like about 2 weeks ago. So we're at version 1.1 of this technology for blockchain right now, and that's where we're at right now. I'm assuming that pretty soon we'll be upgrading to the latest one, but we're not ready there yet. Regarding the production system, our goal is actually to have a blockchain technology system applied to any of the existing systems that you may have already, but the data will just simply be migrated from where it exists right now to a blockchain technology system. We will not be controlling your data. Each association will still have control of their own data. They will assign a sysadmin to control the data and provide access to whoever they want. Another beautiful feature, great feature is that the systems are so secure that so far no one has been able to hack a blockchain system. That's how secure the system is. The Bitcoin system has been online for so many years and no one has actually been able to crack it. So that's how secure the systems are. It's very reliable and it's the latest technology. So how will all the MLSs benefit from this technology? Obviously, as mentioned before, you will be on the latest and up-to-date technology. It's a very secure system with multiple layers of security. It will be redundant nationwide, at least. All blockchains are literally free because they're part of the open source foundation. And for those of you who don't know what an open source foundation is, it's a foundation where developers volunteer their time to actually start fixing patches, bugs, upgrades, all kinds of updates to any of the applications. The blockchain is only a small part of it. Open Source Foundation has many, many tools online, which are all free. Obviously, the administration, the upgrade will take some time and administration and planning, but it will all be free as far as the applications. Another good feature that you guys are going to benefit for with the blockchain systems is that every single transaction, every single event that is updated to the ledger systems are going to have a record of every single checkpoint. The recorder will be actually part of the timestamp, will be part of the log, will be part of the historical record, and everything will be accessible to all members according to how the association will be providing access to the members. Okay, so let's say that members decide on suggesting to use the blockchain technology on a system to keep track of all the members. Let's say that you want a record of every single profile on a member system, right? So I think it exists already on your NERD system. So basically, this system will have multiple copies, first of all, in all of those states, and then each state would actually be in control of their own data. You will decide, assign someone to keep a record and maintain all the data in your system. You will actually provide roles to end users to see the data to whoever you want. It's up to you if you want to make it private or if you want to make it public. Once that's done and decided on, the peers, which is just a system located anywhere in the US, the system automatically syncs itself. It makes a copy from whoever's making the change. For example, in California, they make a change on their system. The other systems in New Jersey, Indiana, they see the copy. They see the update. And they grab a copy of the update and actually commit that change to your local system. So that's the other benefit. Now, as far as security, these systems have not been hacked ever so far, including the Bitcoin systems. They have not been hacked. And it's getting to the point where they're actually making it better. They're trying to actually fix bugs in the versions. They're trying to make it more user-friendly, but the technology will be there for us to use for whatever members want. The main thing that we have been testing is just member activity with events. And when I mean transactions, I'm not talking about property transactions. I'm talking about member information. Let's say that a member gets certified or trained on any field. Okay, that's an event being added to the blockchain system. Once you add that event to the blockchain system, that gets recorded with the person who actually added the data entry, when they added the data entry, and what was the data entry. And once that's done, all of the peers get a copy of that record. And it will be online to whoever the association wants. Well, that completes my time. Angie, if any questions, please feel free to send us emails.